what I'd like you to do is I'd like you to look over these questions, because before we get started on the next class or in the next class, what we're going to do is we're going to go ahead and review some of these questions and look at some of the answers. So have an idea of what everything is on this page is talking about. In this section, what we're going to do is we're going to start talking about ionic compounds, what ionic compounds are, how they're written, and things like that. A couple of things that we're going to do is we're going to specifically look at writing them, and we're going to look at naming them, naming both binary and polyatomic compounds. There are 5 steps to follow when you write ionic compounds. Step number 1 is you're going to write the positive ion first. Step 2, you're going to write the negative ion second. Step 3, this is the one where we are circling just the numbers on the ion charge. We're not going to circle the positive, we're not going to circle the negative, we're just circling the number that's associated with each ion's charge. Step 4, we're going to cross those circled numbers. Step 5, we're going to write the proper chemical formula. If you can reduce charges, do so. Now, like in math, you would never write 2/4. What you would do is you'd reduce it down to 1/2. Same thing here. A 4 and a 2, we can go ahead and cancel down to a 2 and a 1. Same thing here. A 3 and a 3, so if I had a +3 and a -3 charge, I can reduce it down to a +1 and a -1. And the other thing is, if a number comes down on a polyatomic ion, make sure that you are placing it in parentheses. I know this isn't one that you have to know, but this is the polyatomic dichromate. That if we would have a +3 number and that 3 is coming down here, make sure that this whole polyatomic is being placed in parentheses. So for example, barium fluoride. The one thing that I want you to remember is that mnemonic that I gave you for charges. So what we're saying is this first column is going to be a +1. This second column is going to be a +2. We're going to jump over here. The third column is going to be +3. And this is the top of the mountain. And remember, at the top of the mountain, it's going to be +4 or -4. This column will be -3. This column will be -2. And then this column right here is going to be -1. So remember that mnemonic for writing proper chemical formulas, because you're going to have to use those charges. So when we go ahead and look at a couple of examples, barium fluoride. So what I'm going to do is we're going to go through and start looking at our steps. Step number 1. It said write the positive ion first. So barium, symbol is Ba. Now, barium's located in that second column. So since it is located in the second column, it's going to have a +2 charge. Fluoride is just going to be F. Okay? And one thing I want to tell you right now, and we're going to get to this in the second part of naming them, is all of these IDEs will come from the element name. So fluoride will use fluorine. If you see oxide, we'll use oxygen. Fluorine is a -1 charge. Now, we never actually write that 1 down. Okay, the next step is said to circle just the numbers. Now, I know there's no number here, but I'm just going to go ahead and circle air. Next step is said to cross them. So I'm going to go ahead and cross them down. And your correct chemical formula is going to be for barium fluoride is Ba. Notice nothing is circled, so nothing comes down. I go ahead and write my F. Notice the 2 comes down here, and it comes down as a subscript. Now, again, when you evaluate this answer here, notice there are no plus or minus signs in that correct chemical formula. BaF2. Aluminum oxide. Let's go ahead and look at this one. Aluminum, Al. Aluminum is in that third column over, so it's going to be a +3 charge. Oxygen or oxide. Oxide is in that 2- column. Circle your numbers. Circle your numbers. 3 and the 2. Cross, and your correct formula will be Al, the number that came down, the number that came O3. So Al2O3. The next one, iron 3 phosphide. So again, when I look on that sheet, iron is located in the middle of that periodic table. But iron is one that I told you that you're going to have to know. And again, the mnemonic that I told you is basically the Roman numerals give it away. So iron 3 is going to be a +3. Phosphide is just phosphorus. Phosphide is in that -3 column. Now, notice one of the restrictions that I told you are things to watch out for. Look here, I've got a 3 and a 3. So what we can do is we can reduce down or cross those out. So after I cross them out, notice there's nothing there. So I'm going to again circle that air, cross it, and what you'll end up with is FeP. Okay, so those 3's will cancel out because they can actually reduce down. And that last one's going to be ammonium phosphate. Ammonium, that's one of those polyatomics that's on your sheet. So you're going to go ahead and look that one up. That one's NH4. Now, again, polyatomics are groups. Okay, this group right here that I have written down, NH4, that will never change. It'll never be an N2H3. Okay, it's always NH4, and then its charge is a +1. Phosphate, again, that's another one of those polyatomics. So I'm going to first write the group, PO4. Now again, that thing never changes. Phosphate's charge is a -3. I still go through the same rules, circle and circle, cross, cross. So the proper chemical formula is NH4. Now again, when I bring that 3 down, if I put it right there, remember NH4, that was the group ammonium. But if I bring that 3 down, it looks like I have 43 hydrogens. But I don't have 43 hydrogens. What I have is I have 3 of the NH4 groups. And that was that other restriction that I told you had to look out for, that if a number comes down on a polyatomic, you have to put it in parentheses. I'm going to finish off with PO4. It too is a polyatomic, but when I look up here, there was no number circled, so no numbers coming down, so I don't have to put that one in parentheses. So your correct chemical formula is NH43PO4. These two examples, what I'd like you to do is I'd like you to come to class with those answered for me. Write the correct chemical formula for magnesium sulfate and write the correct chemical formula for calcium. Let's look on the other side. Instead of writing them, let's go ahead and name them. There are 3 steps for naming binary compounds. Again, what I want you doing is I want you thinking of that prefix bi right there. Bi just means 2. So what we're saying is we'll only have 2 element symbols. For example, calcium and chlorine. We had that one that was iron and phosphorus. So again, only having 2 elements. Now I do put a little asterisk here, and the reason why I put that asterisk is ammonium will also be included in these steps if you have a single element that is a negative ion. So if I'd have NH4 and just sulfur, or if I'd have NH4 and just oxygen, then it too will also follow these binary rules. The rules for naming binary compounds is write the element name of the positive ion. Write the element name of the positive ion. Step 2, you're going to write the element name of the negative ion. And here's where the difference comes in. What you're going to do is you're going to drop the ending of that negative ion, and you're going to add the suffix at the end, the suffix IDE or IDE. So a few examples here. K3N. So what I said to do was name this first element. Okay, so K is potassium. So I'm going to go ahead, write potassium up here, and I'm just going through and showing you the individual steps. Okay, so K was potassium. N, the element name, that's nitrogen. So again, go ahead and write nitrogen down. Now, step 3 was it said drop the ending. Okay, drop the ending of that negative ion. So I'm going to go ahead and erase it. And when I drop the ending of that negative ion, what it said to then do was it said add the suffix IDE. So the correct name is going to be potassium nitride. NH42, S. Now again, this isn't binary. N, H, and S, those are going to be 3 elements. But again, if you notice here, S is all by itself. And because S is by itself, we can also go ahead and use those rules. So the first, or the positive ion, NH4, that's ammonium. So go ahead and write down ammonium. Write the name of the negative ion. S is sulfur. So I go ahead and I write down sulfur. But then step 3 says drop the ending. By dropping the ending, I'm going to go ahead and erase the U and the R. And then what it says to do is it says go ahead and add the suffix IDE. The correct name for NH4 in parentheses 2S is going to be ammonium sulfide. And then the last one, FR and SE. So FR is going to be francium. Or in the video, as they said francium. Okay, so we got francium. SE is selenium. So go ahead and write that down. And then it says to go ahead and drop the ending of that negative ion. So I'm going to go ahead and erase here the IUM. And when I go ahead and add that suffix IDE, so the correct chemical name for Fr2Se is going to be francium selenide. Now, let's go ahead and look at the rules for naming polyatomic ions. This is the easiest set of rules because there are no name changes like binary compounds. What you're going to do is you're going to write the name of the positive ion just like before. You're going to write the name of the negative ion. And the thing is with this one, there are no name changes at all. I leave this name, and I leave that name. So, Zn, OH in parentheses, 2. So I go ahead and look here, Zn. Zn is zinc. OH, I don't really care about that too. When I look on that sheet, OH is on that left side of your sheet, and OH is hydroxide. Now, I know it has that IDE ending also, but that really doesn't matter. So the name, zinc hydroxide. Number 2, NH4NO3. Again, name each portion of it. So I've got NH4 from that previous slide, and again on the right side of that sheet that I gave you, NH4 is ammonium. And then NO3, NO3 is also one of those polyatomics that I told you I needed you to know. So it is going to be ammonium nitrate. Ammonium nitrate. And then the final example is CuPO4-2. Now, this is one that's going to be a little bit tricky that we're going to have to look at. And you might say, well, how is this one tricky? Well, Cu is copper. PO4, again, PO4 is on your sheet. PO4 is phosphate. But when you looked on your sheet, there was a copper 1 and there was a copper 2. Which form of copper is this? Well, here's the thing. What you really need to do is you need to work your way backwards. If I take that 2 and I bring it back up here, because remember, we always write that positive ion first. So this form of copper, by working our way backwards, has a 2 up here. The form of copper that has a 2 plus charge is going to be copper 2. So the thing is that I'm telling you is if you have a Roman numeral, for example, I know we have copper 1 and copper 2, we have iron 2 and iron 3. If it is one of those, you are going to have to make sure that you are using the correct Roman numeral.